Okay, dear students, this is Michel, right? And today we're going to be talking about hydrocarbons, right? Okay, but the first question that the first question we should formulate is what are hydrocarbons? So let me give you like a short overview about this topic. So you have different types that are known as aliphatic, okay, aliphatic, right? Hmm. And from aliphatic, we're going to find different types such as cyclic, right? Cyclic, and they are also known as alicyclic, okay? Alicyclic. And you're going to find other category that is called the open open chain hydrocarbons that are known as open or acyclic. Okay. Okay. Right. So there is another general category that is related to the aromatics. Aromatics are those ones that are like planar, they are like cyclic at the same time. They present a phenomenon that is called resonance. But I'm gonna talk about this later. Okay. Okay, so let us browse to the next, you know, to the next step. Okay, so here in the cyclic, there are closed chain because they present like a cyclical form. Mhm. So here you're gonna find that they will have single bonds. Okay, they will have single bonds. Okay, and they will have reactions such as the substitution reactions, where they will have to substitute one of the elements that is presenting in the chemical reaction, right? So substitution. Substitution reactions. Got it? All right, so the general formula is going to be CnH2, where N is going to be the number of carbons. So here is where we have an example like the famous cyclobutene. Cyclobutene contains 4 carbon atoms. So I will draw the molecule. It will have 4 carbon atoms, right? And each one of them will contain 4 bonds, right? So I'm going to say that if I apply this formula, if I apply this global formula to this molecule, I would say that C, and I say number of carbons, in this case, 1, 2, 3, 4. So I will write 4 carbons, C, 4, I'm here, right? So H2 multiplied the number of carbons, 4. So I would say C4, H, and 2 times 4, 8. Got it? So that's going to be the formula for the cyclobutene. Okay, so we have other types that are the unsaturated, the unsaturated. They will have reactions that are going to be called addition reactions. So where we'll have to add another element. Got it? Reactions. Okay, so here you can find some examples like the cycloalkanes, and here you will have other ones that are going to be cycloalkenes. When I say alkanes, I mean single bond, simple bond. Okay. When I say alkenes, I mean double bond. Right? And cyclo because they are cyclic, right? For being cyclic. Okay, so this is like the first category where we're supposed to introduce this organic chemistry class. I'd like to talk about the second subdivision, that is the open chain hydrocarbons. They're called also as acyclic. They're known to be acyclic because they are open, right? A in this case means none, okay? Like the word atom, okay? Non-division. Okay, but all right, so let's go back to the topic. So it's like a prefix, it's really important in science, right? So here we have a classification according to the reactivity. So the reactivity in this case is going to determine their classification. Their reactivity, got it? Okay. So here we have both subcategories. Okay, so we have the saturated, okay? But we're gonna have simultaneously on the other side, the unsaturated, okay? Okay, guys, so what I can tell you is that the saturated open chain hydrocarbons, they have single bonds. They're gonna have single bonds. Remember that a single bond is a simple bond, right? One bond. Okay. So bond, a single bond will basically indicates the presence of sigma bonds. Sigma bonds. Okay. So when you see single bond, you're talking about sigma bonds. Got it? So we have here the alkanes, and they are also going to be called as the paraffinic. Okay. So paraffinic because they're inert. Okay. They are inert. I mean, like inert things now. So they have slow reactions. They're gonna be slower. Okay. And our general formula is going to be almost the same, but with certain different +2, right? So I'm going to say that their general formula is CnH2n +2. So this is like we add another +2, right? Okay. The reactions is going to be the substitution reactions. So I'm not gonna talk. I'm gonna talk about substitution reactions. Substitution reactions. So you can say that in certain way when you have alkanes, sorry for that. So you can say that in certain way when you have the alkanes, you're gonna have substitution reactions. Got it? Okay, and their general formula is almost the same. In this case, it's not a closed chain hydrocarbon, but it's an open chain hydrocarbon. So that's why I'm gonna say CnH2n +2. So we're in. What is N? Can you remind me what is N? Is the number of carbons. Okay. So it's really important to talk about the concept that is the tetravalency concept. Tetravalency. Okay. So this concept indicates us that all the carbon atoms are going to have 4 bonds. 4 bonds. And these bonds in most of the situations will be satisfied by the hydrogens. So what I would say is that C will have 1, 2, three, four bonds. Got it? So normally we have another element that will help the carbon to be bonded, which is hydrogen. And hydrogen will have one bond. Got it? So what I will say is that hydrogen will be bonded one time. And why? Why does it happen? Right? So not in this video, but in other, I will explain you quickly. Because the group for carbon in the periodic table is going to be the group number 4. So carbon will be located in the group number 4, right? So remember that we have the periodic table divided in different groups. So we have group number 1, group number 2. These are transition metals, okay? Group number 3, number 4. And the carbon will be especially in this group. Got it? Okay, I'm gonna color this location with blue color. Okay, while hydrogen will be in the group number 1. Hydrogen is in the group number 1. So remember that there is a concept here that states that all the elements in the periodic table they want to be as noble gases. So the octet rule states that to form a stable molecule, okay, I'm summarizing this rule. Obviously, it's more precise in many, but I'm just summarizing. I'm just summing up. So to form a stable molecule, all the elements, all the atoms will have 8 valence. When I say valence, I mean the outer electrons, okay? The ones that are in the outer shell, okay? So all the atoms will have 8 valence electrons. They will have this tendency, right? But all right, so let's go back to the topic. So that's why you're going to find normally a carbon bonded to a hydrogen or vice versa, because that's what happens. Okay, so here we have different examples. Remember, okay, let's go back to remember what we're talking about. So we were talking about hydrocarbons. We had the cyclic, right? That are a closed chain. And we had mentioned they are like, they have like this cyclical geometry form, right? Like cyclobutane. And their formula was CnH2n. But now we're talking about the open chain hydrocarbons that belong to the category of aliphatic, right? And you can find single bonds in this type of hydrocarbons because they are saturated. And when I say saturated, I mean that they are saturated of, okay, in some books you can find that they are saturated of hydrogens. In other ones, you can say that you can visualize, you can find out that they are saturated of covalent bonds, right? There are the bonds that are presented between 2 nonmetals, right? Okay, so there are types of bonds where sigma bonds, they are classified as alkanes, also known as paraffinic, because they are inert, and the reactions are slower. So they have substitution reactions, being their global formula CnH2n plus 2. Okay, that is the number of carbons, right? Okay, then we have the tetravalency, right? That states that all carbons will have 4 bonds, right? Because the carbon is in the group number 4. So if you analyze its oxidation number, that is +4 or -4. That means that the carbon atom can donate or can gain valence electrons to complete and to accomplish with the octet rule. Got it? So let us approach to this topic. So In this case, hydrogen will have one bond, and hydrogen will help the carbon to satisfy the octet rule. Got it? Okay. Okay, so let's go back to the substitution reaction. CnH2n plus 2 is this global formula. So I have an example here, yeah, such as methane. Methane contains one carbon. But why one carbon? Okay, because the prefix, okay, met means one single carbon. So I'm gonna copy and paste this image, and I extracted it from science notes. Okay, so I will copy paste the hydrocarbons prefixes in chemistry. This is a link. Okay. Hydrocarbon prefixes in organic chemistry. I didn't design this content, but we're gonna use it for a while. So for example, guys, when you have met, that means that you have only one carbon. Et, 2 carbon atoms. Prop, 3 carbon atoms. But means 4 carbon atoms. Pent, 5. Okay, hex, hept, oct, non, and dec. Really important to understand that you just have to learn these 4. Why? Because the other ones are really close to the geometrical figures. If I draw this figure, how many sides does it have? 1, 2, 3, 4, 5, 6. So what is an hexagon. So we're going to be using its prefix, its prefix. So people say. Okay, so let's suppose that I have this other one. How many sides does it have? Okay, 1, 2, 3, 4, 5. So what do I use? What is the name for this? It's a pentagon. You see, because it has 6 sides. The same would happen with this system. So you can find methane, for example, in the greenhouse gas effect, no? I would say methane will have 1 carbon atom. Okay. But what about the next one, which is ethane? Okay, how many carbon atoms will it have? 2 carbon atoms. Propane, it will have 3 carbon atoms, right? Heptane will have 7 carbon atoms, and so on. So according to my molecular, my global formula, that is CnH2n, this one that is here, what I can say, plus 2, right? What I can say is that for methane, that is this one, we have only 1 carbon atom, right? So if I apply this to my formula, I would say C1H2 times 1, because N equals 1, plus 2. And I can say that C1H2 times 1, 2 plus 2, 4. That's why I would say CH4 is methane, right? So I'm gonna give you, I'm gonna assign you an exercise. You'll try to do it. So what about ethane? How would you represent this if you know that the molecular formula is CnH2n plus 2? So I say that ethane contains 2 carbon atoms. Let's say 2 carbon atoms. So I replace it. C2H2 times 2 plus 2. And I would say that the global formula for ethane would state that this molecule can be represented as C2H6. Okay. And this is the formula of ethane. Okay, so I'm going to assign you the next exercises, and I will show you the answers. Try to encounter what is each one of these exercises global result. Okay, so I will assign you the molecules. Try to find propane, and I mean propane contains 3 carbon atoms. Try to find heptane, that is 7 carbon atoms. Okay, we can find heptane to test, for example, the gas quality, right? And for example, propane can be used in gas cylinders. Gas. This is for gas quality. Okay. So, for example, okay, let's try to do it. I will give you 2 minutes, and you can pause this video and then play a game to see what are the answers, right? So for propane, okay, for propane we say C3H8. Got it? That is the answer. And for heptane, right? And for heptane, you can say that is C7H, so H16. Got it? C7H16. All right, let us check this other concept. All right, let us check this other concept. All right, so here I would like to point out that, for example, the olive oil is not recommended to be burned, right? To be exposed to its boiling point. And because it contains sigma bonds. As it contains sigma bonds, all right, so here again, okay, so here you have an assignment for you, and the assignment is research why it's not a good idea. It's not a good idea to expose olive oil to high temperatures. Okay? So you have to research about it. Why? What types of bonds are present here? Sigma or the other types of bonds that are called pi bonds. Okay, so let's see. Let's go back to this type of hydrocarbons. Then we have the other ones that I will draw with this other color to be easily identified. Okay. Then we have the unsaturated hydrocarbons that are also known as open or acyclic, right? So in this case, we're going to have sigma bonds that can be double bonds, okay, due to this unsaturation of a compound. When I say unsaturated, I mean that they are free of covalent bonds, right? I mean, not at all, but okay, they in certain way, they don't have all these hydrogens being bonded to the carbons. Okay, so we have the alkenes here. And when I say alkenes, I mean double bond. So remember that alkanes was a single bonded, but alkenes are going to have a double bond, right? Okay. Right, but it can have also one, it can have two, it can have three or more double bonds. Got it? Okay. They are known as oleophilic compounds. Okay, so they will undergo some reactions that are known as addition reactions. Addition reactions, where the pi bonds will be broken. Okay, but that's something I will explain you then. That's something that I'm going to explain you then. Okay, so the general formula is CnH2n, and it's similar to that one that we saw in a cyclic saturated cycloalkanes. Got it? So they will have CnH2n, and this formula is similar to this other one. Okay? But in this case, we're talking about unsaturated hydrocarbons. Okay, so here we're going to find that they will undergo addition reactions where pi will be broken, as I showed here. And we also have the other group that is called the alkynes. And alkynes, they will have first, at least, here's where we have alkynes, and alkynes will have at least one triple bond. Got it? They are also known as acetylenic. So they will be acetylenic compounds, and they also undergo addition reactions. Right? So the general formula can be different in certain cases, but I'm not going to ask you about it. Only when they have one triple bond. Okay, because if they have different more than one, for example, this formula can vary, right? But we're not going to talk about that. What I need to do is basically to give you a panorama about what a hydrocarbons can be in their categories. Right? Okay, guys, so let's go now with the second category of hydrocarbons. So remember that these ones were subcategories, right? So let's go with the second category of gray category of hydrocarbons. Okay, here is where we have all the molecules that comes from one famous and special or popular molecule in chemistry that is called the benzene. So the aromatics are going to be, they're going to be planar. Give me a second. They're going to be planar, guys. They are planar cyclic substances. Okay, so they present a phenomenon, as I told you in the beginning of this video, that is called the resonance. But what is that? Okay, all right. So let me throw this concept up to you easily. So here we have the benzene molecule. It will have six sides, and each one of these sides will contain double bond. So we're going to have like an alternating double bond, right? Double bond, no double bond, double bond, no double. So we have double, single bond, double, single bond, double, single bond, right? So basically, in this case, it will be kind of hybrid molecule because we'll be combining double and single bonds, right? So we can say that here we have pi bond, and this pi bond in the next time will be located between these two atoms. Remember that each one of these points represents a carbon. Okay, so we have 6 carbons here. Let me show you 1 carbon, 2 carbons, 3 carbons, 6 carbons in total. right? 1, 2, 3, 4, 5, 6. Okay, so they will be basically exchanging their positions. So this pi bond will be next in this between these two carbons, right? This other pi bond will be between these two other carbons, and so on, right? So what we will have is that in the next situation, we'll have the same molecule, but the carbon, the double bonds, the pi bonds will be in different locations, different positions. Got it? So all the aromatics come from this molecule. Um, and then the result will be the resonance. The resonance indicates that these bonds will be spinning, right, constantly. And that's why we write a circle to represent the molecule that is called as benzene. Okay. All right, guys. So that is like a short introduction on what we're going to see in this course. So if you have any question, I'll be here to answer your question. My advice is try to be patient and let's move forward. This is Michel Wright. Bye-bye.